We can also derive the decimal equivalent of a binary number. We can do that by using the positions of the binary digit, starting from the rightmost or the lowest bit by assigning it a value 0 and then incrementing as we move towards the left. Now we derive the decimal value at a particular position by multiplying its Boolean value with 2 raised to the power its position. And similarly, we calculate the decimal value at each position and then add all the resulting values that should give us back our decimal number. If you have understood this much, then it will help us in figuring out the limits of different data types, especially the integral data types. We can quickly calculate the maximum and minimum values that a data type can accept. Typically, we don't need this info to declare or use our variables, but it will help provide that conceptual clarity that a Java developer must have. And also, oftentimes, developers need type conversion, means converting one data type to another. And an incorrect understanding of data type limits can result in possible data loss, which can be fatal. Imagine you are a lead programmer at a unicorn company which is developing applications for driverless cars. Imagine what could be the repercussions of such a type conversion data loss. It can result in a fast-moving car to unwantedly drift a couple of inches away from its path. And these couple of inches could be the distance between life and death. Let's begin with calculating the limits of an int data type as an example. Here we can have a max value when all the bits are 1 except the sign bit, which should be 0. So if we apply the same formula to get the decimal value for each bit and then we sum it up, we see that it looks like a geometric series where A represents the first number, which in our case will be 1. R represents the ratio between consecutive numbers, which in our case will be 2, and N represents the number of terms in the series, which in our case will be same as the number of available bits. And for an int data type, it will be 31 since we ignore the sign bit. So the formula becomes 2 raised to the power n minus 1 divided by 2 minus 1, which is same as 2 raised to the power 31 minus 1. And that's max value an int can achieve. Similarly, the minimum value should be the negative of the max value, but I'm afraid that's not the case. Rather, the min value is 1 less than that, which means it is negative of 2 raised to the power n instead of negative of 2 raised to the power n minus 1.